Welcome, everyone, to another session on Dr. Liu's VCE Physics channel. In this video, we'll be tackling the magnetic field questions from the NHT 2024 physics examination. I'll be guiding you through the solutions and concepts, and I encourage all teachers, parents, and fellow students to contribute any insights or corrections you may have. A DC motor consists of two magnets, a single wire coil, a split ring commutator, and a battery. Conventional current flows from the positive to the negative terminal, causing the coil to rotate clockwise. Consequently, the magnetic force acting on the left side of the coil must be directed downwards. We apply the right-hand rule to determine the direction of the magnetic field. The thumb indicates current, the palm points downwards for the magnetic force, and other fingers show the magnetic field from Q north to P south. An electron enters between parallel plates P and Q with a magnetic field into the page. Since it's undeflected, the electric and magnetic forces must balance. If the electron moves right, the magnetic force is downwards by the left-hand rule. To counteract this, the electric force must be upwards. Therefore, plate P is positive and plate Q is negative, as a negative electron is pushed up by a positive top plate and repelled by a negative bottom plate. Since the electron passes undeflected, the magnetic force and the electric force are balanced. The charge Q cancels out. Solving for the magnetic field, B. To calculate a numerical value for B with two significant figures, please provide the values for E, electric field strength, and V, electron velocity. When a proton replaces the electron and passes undeflected through the same fields, the magnetic force becomes upwards and the electric force downwards. The magnitudes of both forces remain unchanged. The original plate setup, P positive, Q negative, therefore, works for the proton as well. A long vertical copper pole, serving as a skyscraper's lightning conductor, is situated where Earth's magnetic field, B, is horizontal and points north. The magnetic force on this conductor is the product of the magnetic field strength, the pole's length, and the current. Final numerical results require two significant figures. If the current passing through the lightning conductor remains the same, but its length increases, the magnitude of the magnetic force acting on it will increase. This is because the magnetic force is directly proportional to the conductor's length. A lightning flash, characterized by 500 kV and 80 kA, persists for 120 microseconds. The electrical energy generated is the product of its voltage, current, and time. Particles P and Q, despite having identical charges, possess different masses. Both enter a uniform magnetic field within a mass spectrometer, at the same point, and with the same speed. Since the radius of a particle's path in this setup is directly proportional to its mass, and particle P's radius is larger than Q's, it indicates that the mass of particle P is greater than that of Q. The magnetic force acting on particle P provides the centripetal force for its motion. Observe that the speed, v, term appears on both sides. By cancelling one v, and rearranging the equation to solve for mass, m. Please provide the specific numerical values for the charge, q, magnetic field strength, b, path radius, r, and speed, v, for particle P to determine its mass. The magnetic field section is valued at 18 marks, contributing 13.8% to the total of 130 marks. Multiple choice questions, 1 mark, Question 5 addresses the polarity of magnetic poles and the direction of coil rotation in DC motor construction. Short answer questions, 17 marks. Question 1a and 1b1 assess the measurement of charged particle speed using perpendicular electric and magnetic fields, including calculations for the magnetic field strength required to keep an electron undeflected. Question 1b2 examines the conditions for an undeflected proton replacing an electron in the same setup. Question 3 covers calculating the magnetic force on a vertical copper pole and its relationship with conductor length. Question 5 focuses on mass spectrometers in separating charged particles by mass. This involves determining greater mass based on path radius and calculating a particle's mass from given parameters. If you need my help, you can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.